Hello everyone, welcome to Apna Guruji, and in this video we are going to study about energy and power. That is the fourth chapter of class ICSE 8, and in this video we are going to study the full details concept of the chapter work, energy and power. So the chapter name is energy and power, but we will begin with work, because without understanding work you will not be able to understand energy. So first thing, you do various things in your daily life like reading, speaking, singing, writing, thinking, etc., right? So you maybe think that everything that you are doing, that will be work, but we can simply define the work as two types, that is one physical work and a mental work. So we are reading, or we are thinking about something, so that will be the mental work. But in physics we are going to study about physical work. So in physical work, if you lift a dumbbell or you are pushing a wall, so in this case if you lift a dumbbell from the ground to upper, so in that case the body is moving somewhat, but you are applying force upon a wall and it did not move anything, but you are getting tired. So you might be thinking that you have done work, but it is not the work. So in simple language, if you define work, so work will be if you applied force upon a body and the body get displaces, then the work is said to be done. If you applied force and body does not displace, in that case you cannot say that the work is done. So scientifically, work is defined as the work done by a force that causes displacement in object. So whenever body moves, it covers some distance. The straight line from the initial position to the final position, that is called displacement. So distance is different thing and displacement is different thing. In displacement, but the SI unit of distance and displacements both are same, that is meter. So in simple language you can call the distance is a scalar quantity, but displacement is a vector quantity, because scalar quantity only have the magnitude, but the vector quantity both have magnitude and direction. So distance doesn't have any direction, so it is only the scalar quantity, but the displacement, it both have a particular direction and quantity, that's why it is a vector quantity, but the unit are same. So if you take an example, so a boy is going from this point to this point, and whatever the path is covered, that will be its a distance. But if you observe the displacement, the straight line from the initial position to the final position, that will be your displacement. So if a man is going from A point to B point, and then comes to A to C, so or if the man is going from B to A and A to C, then the total distance covered is 5 meter plus 2.5 meter, that will be its total distance. But if you calculate the displacement, then this is a right angle triangle, you can see that. So if you draw this line, so this will be its hypotenuse, and if you find the hypotenuse value, then you will get the displacement. So displacement is the uh, shortest distance or shortest path from the initial position to the final position in a straight path. So the distance will be 12.5 meter, but if you calculate the displacement, that will be your 5.6 meter. So can you name the force against which work is done in this case? So there is a book on the table, so you applied force to move the book. So in this case the force is applied against the frictional force to be the work done. So you have to overcome the frictional force to the body to be moved. So this is example. And if you lift that book to upward side, so you are applying force, and the force is against the gravitational force. So whenever work is done, you have to apply force against some causing force. uh, if you push a trolley to pull up books, then it will move through a certain distance. In this case, they applied force and a displacement in the trolley. Do you think any work is done on the trolley? So work done by constant force. So in this case, a wooden block is kept on a table. When force of magnitude F acts on the block, it gets displaced through a distance s. The direction of the applied force as shown in the figure. So we are applying force to this direction, and distance occurs also in this direction. So if you want to find that the value of work done, so it depends upon two factors, that is applied force and displacement. So force is applied in the direction and displacement is also in the same direction. So the work done will be force into displacement. So simply product of force and displacement is your work done, that is W equals to Fs. So if you find the SI unit, so we know that the unit of force is Newton and the unit of distance displacement is meter. So the work done will be Newton meter, hence unit of work is Newton meter. The owner of physics is James P. Joule. Identify this, that's why it's SI unit written as joule. So hence 1 joule equals to 1 Newton meter. Then comes to energy. So energy nothing but the another form of work also. The work done is, the units are same, but the ability to do work, that is energy. If you calculate, so that is also the value you get, that is also work done, but the defining way is quite different. So energy defined as the ability to do work. So force displaces an object along direction, we say force does the work. So uh, the amount of work you are doing and the ability to do the work, that is your energy. So a strong man lying on the ground, a stone is lying on the ground and stone is lifted up. So in this case you are applying force and the body get displaces. To do these things you need the energy. Energy required to do some work. On the other hand, if some work is done in a body, then the spent energy gets stored in the body, instant becomes capable to do some work. So the energy is divided into two types. That is, one is your potential energy, another is your kinetic energy. So whenever the body is in rest, the energy possessed by the body, that is potential energy, and whenever the body is in motion, the energy possessed by the body, that is known as kinetic energy. So first we will discuss about potential energy. So an object possesses potential energy by virtue of its position or height. You can say in simple language that the energy possessed by the body uh, in the position of rest, that is known as its potential energy, or position and height, you can say that, because if you add the height then it is easy to find the potential energy in case of gravitational force. Take a rubber band and stretch it. When you release on a rubber band, it returns to its original position. So how do you think that when we stretch the rubber band, it comes to its same position? Because it stored some energy and that energy converted it to store it. Take a spring loaded car and when it using its key, when you release it on the ground, the car begins to move. How did you get this energy to move? In these cases, it's all due to the energy. So in the rubber band case, that is known as its elastic potential energy, because when you stretch the elastic rubber band, so it stores some energy when it is rest. When you release it, it's converted into potential energy and then it gets replaced, get to its original position. So that energy is known as elastic potential energy. And the potential energy of an object at height, in this case you will get the formula to identify or measure the potential energy. Suppose an object is in this position of mass m and it is height h1 at the reference level, and then second reference level is h2. So if we calculate the potential energy, it depends upon height. To height will, if height will vary, the potential energy will also vary. So gravitational potential energy depends upon reference level. So if the height is h1, then the formula will be mgh. So the force will be mg because mass into acceleration due to gravity, that is your force, and h is the displacement here, because when you when you put the object here, so the force is applying upon it due to the gravitational force, and the gravitational force equals to mg, and distance will be covered from h1, so that will be displacement u, so that's why it is h1 equals to mgh, and in the height h2 equals to mgh2. So the change in potential energy due to change in height, that will be mg h2 minus h1. If h1 is 0, then h2 equals to h, you can change the formula, that is mgh. So that is the formula of potential energy. Remember this formula when we are solving some problems. In this case we are using this formula, that is mgh. M is the mass of the body, g is the acceleration due to gravity, and h is the height. Here is example. What is the potential energy of a body of mass 2 kg kept at a height of 10 meter above the zero level? So you can simply put the formula, but here also given that the value of g equals to 9.8 meter per second square. that is the acceleration due to gravity. So when you know that the formula of potential energy, that is mgh, here mass is 2 kg and acceleration due to gravity is 9.8 meter per second square and height is 10. So if you multiply both all those three, then you will get 196 joule, and the potential energy of the body is 196 joule. Here is another question also. The potential energy of an object of mass 10 kg increases by 5000 joule when it rise up the height h. What is the value of h? So as before we have discussed h1 and h2, you can use that formula and you will get the answer. Try to solve these questions. If you find the answer, take a pause, and if you find the answer, please comment, give the answer in the comment section. Then we'll move forward. I hope all of you got the answer. If you feel some trouble to get the answer, then you can see the solution also. The potential energy of an object is given as mgh. Here mass is 10 kg. H due to gravity is given as 9.8. Potential energy is given 5000 joule. So H equals to 51. That is potential energy is 5000 joule, and your formula is 10. That is the mass into acceleration to gravity and H. So H will be your 5000 by 98. That will be 51.02 meter. Okay, then another question also. N book each of thickness d and mass m lie flat on a table. How much work done is required to stack them on the top of another? So this one you will solve by yourself and give the answer in the comment section. And then next comes to potential energy and work. So what is the relationship between the potential energy and the work? So work has to done rise the potential energy of a body. The work done is changing the position of a configuration of a body is stored in the body as potential energy. Suppose a body of mass m initially at height h1, and this one the h1, and a force and then taken to height of h2, then it goes to height h2. A force equal to its weight mg is applied to increase the height, and the body is moved to zero acceleration. So the work done by the force mg is displacing the body from the height h1 to h2. So w equals to mg h1 minus h2. This is the expression, the same way changing the potential energy of a body. Thus we say that work done in changing the height stored in the potential energy. So this is the relationship between work done and the potential energy. So you can say that work done is equals to the change the height of the object from one position to another position, that is related to your work. So energy stored in a compressed spring. So in this way there is a normal position, then the spring is normal position. When you compress it, so the distance will be changed as the distance is measured x, and that will be the work done compressing the spring to found to be w equals to half k x square. So this is another expression also. And then comes to our kinetic energy. So kinetic energy is simply the energy possessed by the body by virtue of its motion, that is known as your kinetic energy. The world requires a lots of energy to satisfy its demand. We have a natural energy sources such as sun, wind, water, and high tides and low tides. We have also artificial energy sources such as petroleum and natural gases. You can use you are using it your vehicles to move. So these are the energy sources. Energy exists in various forms such as light energy, sound energy, heat energy, mechanical energy, electrical energy, chemical energy, nuclear energy. These are the various forms of your energy. So next we get details about kinetic energy. So kinetic energy is simply associated kinetic energy associated with the motion, and potential energy will associate with the object in rest. In the kinetic energy, the energy of a body by virtue of its motion is called kinetic energy. Its units will be also joule. So if you want to find the formula of the potential energy, suppose a body of mass m is moving with uniform velocity u. Let's the external force is applied upon it F, and the displacement of the object is s, and the velocity becomes v. So initial velocity is u and the final velocity is v, and the force is applied F. So we know that the relation that equations of from the equations of motion, that is v square minus u square equals to 2s, or v square equals to u square plus 2s. So in that way s equals to v square minus u square by 2a. So here is the displacement we have already got from that formula. So here u is the initial velocity, v is the final velocity, a is the acceleration. So we know that the work done is force into displacement, but we also know that the formula of force is force equals to ma, that is mass into acceleration. We can replace these values, the value of s into this, and the value of force equals to ma, that w equals to ma into v square minus u square by 2a. So that will be A and A cancel, and you will be getting half mv square, or half mv square minus u square. If the body is initially at rest, then u will be 0 and you will be getting w equals to half mv square. So this is the formula of kinetic energy. In the previous I have already mentioned that the units of work and energy are same. So we are obtaining the kinetic energy in the form of work also. So that kinetic energy ek equals to half mv square. The kinetic energy of the body is directly proportional to mass and the square of the velocity. So if the mass is increasing, the kinetic energy also increase. If the velocity will increase, it's also increase. If both are decrease, then the kinetic energy also decrease. It is the kinetic energy of the wind. If it is the kinetic energy of the wind that is used for generating electricity through windmills, the relationship between kinetic energy and momentum. So if you know what is momentum, momentum is mass into velocity, or the amount of motion contained in a body, that is known as your momentum. So we know that kinetic energy formula is half mv square, and the momentum is mass into velocity, that is p equals to mv. From equation 1 and 2 you will get half mv square. In case of v square, you can simply put v equals to p by m. If you replace p equals to mv, then v equals to p by m. So you can replace the value of v in position of p by m. So that will be half m pm by p by m square. That will be half pm square by p square by m. So p square equals to 2m kinetic energy, that will be root of 2m kinetic energy. This is the relationship between the kinetic energy and the momentum. Then next come to the work energy theorem. So work energy theorem stated that the work done on a body is equal to the change in the kinetic energy. So whatever amount of work is done, it is the equal value of the change in kinetic energy. So we have taken example. Here the body is in rest, and if we apply force upon it, the initial velocity is u and time is t1, and then we apply force upon it and the final velocity is v and the time is t2. So from the third equation of kinetic distance and s travel is kinetic equation of motion, that will be v square equals to u square plus 2s. In that case, you have multiply mass on both sides, then mv square equals to mu square plus 2ms. So if we divide 1 by 2 in the both sides, then it will be half mv square minus half mu square, that is equals to mas. And we can replace that half mv square, that is the final kinetic energy, and it is the half mu square will be the initial kinetic energy, because half mu square we previously discussed about that. That is the formula of kinetic energy. So fs equals to half mv square, and mass ma equals to force, and s is the displacement. So force into displacement equals to you getting half mv square minus half mu square, that is the work done. Fs is the work done, and half mv square will be the final kinetic energy, and half mu square in the initial kinetic energy. So that is the relationship between the work done and the kinetic energy. So this is work energy theorem, that is work done equals to the change in kinetic energy. Then conservation of energy. So conservation of energy is energy neither be created nor be destroyed, it only transform from one form to another form. Like if you discuss about potential energy and kinetic energy, when the body is in rest, this will have a maximum potential energy, and when it starts in motion, the potential energy converts into kinetic energy, and again when the body getting in a rest position, the kinetic energy changes to its potential energy. So energy neither be created nor be destroyed, it can only transform from one form to another form. The law of we have already stated that the sum of kinetic energy or potential energy of a system is called mechanical energy. So in total, that both, if you both add the kinetic energy and potential energy, if you will get the mechanical energy. So in combined form, they are known as mechanical energy, or you can simply state it that mechanical energy is divided into two types, that is kinetic energy and potential energy. So change in mechanical energy equals to change in kinetic energy plus change in potential energy. So we have a question. So many forms of energy are observed in nature. How do you use these forms of energy in your daily life? The chemical energy stored in an electric cell can be used to power a bulb to produce light. Where does its light's energy come from? So in this case, we are using the chemical energy convert into electrical energy, and the electrical energy converts into light energy. There are another questions. How the transformation of energy takes place in the wind up toy car? What is the prime source of energy in this process? Do you know how many toys how know any more toys that work on simple same principle? So if you know, please give the answer. So in this basis, the change in kinetic energy and potential energy, this will work. Then the free fall body, in the free fall body, the body is in top position, then the kinetic energy will be 0 and potential energy will be mgh. And if it cross x distance, then the kinetic energy will be mgx, and energy if it is in ground position, up to the ground position, then the kinetic energy will be maximum, that is mgh, and initial potential energy will be 0. This way the potential energy converts into kinetic energy, and then again kinetic energy to potential energy. If the body touches the ground and becomes rest, then the potential energy also maximum and kinetic energy will be 0. Here the curve is showing. So total energy equals to kinetic energy plus potential energy. It is converting. Conservation of mechanical energy in simple pendulum. In simple pendulum, we have a pendulum. In this case, when it is moving, we show some position A, B, C, D, and E. So you can say in the case of A position, there is only potential energy. In case of B position, both potential energy and kinetic energy. In C position, it have only kinetic energy, 0 level, and in D position, both potential and kinetic energy, and E level, it is only a potential energy. Then again, its potential energy converts into kinetic, maximum kinetic, then both potential and kinetic, and then again into potential. Then we have question. Two bodies of masses 6 meter, two bodies of masses 6 m and 12 m are kept at a height of h and 2h from a reference level. What is the ratio of potential energy of the masses? So mass of A is 6 m, height of A from the ground is h. So potential energy will be 6 m gh. So 6 m gh, and mass of B is 12 m. So its potential energy will be 12 mg 2h, that will be 24 mgh. Therefore the ratio of them is 6 mgh by 24 mgh, that will be 1:4. Then another question we can solve, that is a ball of mass of 200 gram is dropped from a height of 10 meter. What will be its velocity when it hits the ground? Take the value of g equals to 9.8. So by the law of conservation of energy, loss in potential energy of the ball equals to gain in the kinetic energy of the ball. Loss of potential energy equals to mgh. Here m is mass of the ball, that is 200 gram. G is the acceleration due to gravity, that is 9.8, and h is the height, that is given as 10. So gain in kinetic energy will be half mv square. Here v is the velocity of the ball when hitting the ground. According to the law of conservation of energy, mgh equals to half mv square, because both are same. So v square equals to 2gh, because here m and m will cancel and gh will be equals to half b square, that will be v square equals to 2gh. So v square equals to 2 into g value is 9.8 and h value is 10, so 196. Then v equals to root of 196, that will be 14 meter per second. So these are very easy questions. Then here next questions for you. Two objects of masses m1 and m2 have the same kinetic energy. Both are stopped with the same retarding force F. If m1 is greater than m2, then which mass will be stopped in shorter distance? So take a pause and try to solve by yourself, and please answer in the comment section. This is the solution. You can look at this and you can solve this way. Then comes to power. Power is the rate of doing work. So how much work you are doing in how much time, that will be your power. If you are doing a lots of work in less time, then you have a lots of power. If you are doing much you have doing a smaller work in greater time, then the power is low. So if we give the definition of work, that is power, that is power is defined as the rate of doing work, and the SI unit is watt, which is joule per second, because the work done per time, that is the work done unit is joule and time unit is second, then that will be your joule per second. So power equals to work done by time taken, that is P equals to W by T. Then power is also defined as the product of force and average speed also. That because we can state it as work is force into displacement, and the power formula is W by T. Then W equals to Fs by T, but SV equals to S by T, so you can replace S by T also. So that power equals to force into average speed also. So you can define power in this way also, that is power equals to force into average speed, or you can simply state that force equals to work done by time. This is the same scientist James Watt who introduced Watt. So by his name the Watt unit is used. Then we have some example. A body does 100 joules of work in 10 seconds. What is his power? So simply work done, power is work done by time. So here work done will be work done is given as 100 joule and time taken is 10 seconds. So power will be 100 by 10, that will be 10 watt. So it is very easy. There is another question. A pump lifts 10 kilograms of water in 2 seconds to the top floor of the house from the ground. The height of the house is 10 meters. What will the power? Take G equals 9.8. So we need to find the work done first. So work done will be mgh because its height is given. Then G equals to 9.8 and mass is 10 kg and height is 10 meter. So that's why work done will be 10 into 9.8 into 10, that will be 980 joule. And the time taken to lift the water is 2 seconds. Then power will be W by T, that is 980 by 2, that is 490 watt. Another example is for you. Water is to be pumped filled tight tank of volume 30 kiloliter 30 kl at a height of 4 meter from the ground in 14 minutes by the water pump the ground floor. What is the electric power consumed by the water pump? Efficiency of the pump is 30%. Density of water is 1000 kilogram meter cube per meter cube and G equals to 9.8. You can take a pause and solve these questions, and please answer the answer in the comment section. There are examples for you. This is the last example. So in this way we have covered all the topics of the chapter power, energy and power. So if you learn something from this video and get interested in this, so please like, share and subscribe, and stay tuned in Apna Guruji for upcoming videos. Thank you guys for watching.